Hi there, it's me Amar Kumar Mandal. I am a third year student studying computer engineering at Kathmandu University. Today I am here to present my mini project of computer graphics on plotting polar curves using OpenGL. This implementation was done on Python programming language. Now let us move to the coding part to see the actual implementation. So I will start by displaying the output. I will run this file. Now it will ask me to enter the value of a which is a constant. Suppose I enter the value 40. Now we can see there 4 cardioid has been generated of different format. One is turned left, another is turned right, another is turned up, and another is turned down. These two are symmetric about x-axis and these two are symmetric about y-axis. Now let's see what is happening behind the scene. So let's start from the main section. So it asks the user to input the value of a. Now if a is lesser than 0, it will ask the user, it will just print that the value of a should be greater than 0. Otherwise it will create an object from the class name Cardioid family. Now let's see what this Cardioid family holds. So Cardioid family contains many methods. Now let's see some of the important methods here. Now set window is just used to set the window of appropriate dimension. So we can see GL matrix mode is set to GL projection and GL load identity, and GL auto 2D is used to define 2D two-dimensional view. Now another important function is set viewport, that is used to define the viewport of appropriate dimension within the window. Now this is the main function that is used to plot the cardioid about x-axis, or that is symmetric about x-axis. Now let's see. First of all, we have defined the point sizes, that is 2.22, and then GL begins. We have 5 GL points, so every point is treated as a individual entity. Now since it is symmetric about x-axis, we can just instead of doing 0, 360 degree, we can minimize this operation to 0, 180 degree. Now we are converting the degree into radian, and then we are checking what is the direction of the cardioid. If the direction of the cardioid is left, then we are using this formula to display the left cardioid. Otherwise we are using this polar formula to display the right cardioid. Now another important thing is conversion. Since the OpenGL do not directly support plotting into polar format, I have converted this into rectangular coordinate system. So this is the formula. So now to convert from polar to rectangular, r cos theta for x-axis and for x, and y cos theta for sine. So using the similar convention, I have used this to convert that r into x and y, and adding this center to it so that it will display correctly. Now this is calculating the symmetry value. Since it is symmetric about x-axis, we can obtain the symmetric x and y points as by using this formula. Now GL vertex 2f is used to plot the individual points, and this is another GL vertex that is used to plot the symmetric point. Finally we flush the output, or GL flush is used to display the output onto a screen. Now another important method is draw vertical method, which is just similar to the above one, but only there is slight difference. It uses since it is vertical about y-axis, we have to look through 90 to 270 degree, and other are calculated as shown above. Now this is another important function that is used to display and configure everything regarding OpenGL to display the output. So I have already talked about self-set window method, which is used to set the window of appropriate dimension. I have and I am passing 800 by 600. 800 is the width and 600 is the height. Similarly, I have set the viewport, and then I have called the draw horizontal cardioid function by passing these three parameters. So left determines that the cardioid should be left, and these two are the centers, x center and y centers. Now finally, GL color 3F. GL color 3F used to determine the color by using which the uh, object displayed. So it is in the RGB format. So RGB means G means it's green. Similarly, color is specified and other different shapes are drawn. Now it's time to move to another portion of the code, that is the Limacon. Now all the other configuration are same, just there are difference in the formula. So here we can see it is for the symmetric about x-axis. Now this is the formula: a minus b into cos theta and a plus b into cos theta for left and right respectively. Now we are calculating the symmetric point as seen in cardioid. Also we are defining another method that is used to draw the vertical Limacon, and we are using this formula sin theta. There is only changes in sin and cos. So now we are calculating the symmetric points here as well, and plotting these symmetric points, and flushing the output to the screen. Now let us see how this show screen function is working. So first of all, I have configured to set the window and viewport. Then I am calling the draw horizontal Limacon function, which take the 4 value. And now let's see what are the values taken by this. So first is the xc is a first value, parameters, first argument represent the xc. There is a center x value and center y value. Similarly, a and b are constant. And now direction is always right by default. If we are plotting the horizontal axis, and direction is always off when we are plotting the curves that is symmetric about y-axis. Now these are the centers, and these are the constant value a and b. Now let's see what the output looks like. So this is the output of our Limacon. So we can see these are the Limacon that is symmetric about y-axis. So this code generates 4 Limacon that is symmetric about y-axis of different value a and b. This a and b are the constant. Similarly, we have another set of code that is used to generate the horizontal Limacons. So these are the horizontal Limacons. Now let us move to the final portion of the code. Let us start by displaying some output. So this is the output of the rose petals. So they are organized into their centers are organized into a linear fashions. So let's see how this works. At first, I will create an object of rose family, and register a show screen method. Now we can see show screen methods contain a multiple sub methods and statements. So one important statement is self.draw rose sm h underscore axis. It means that draw the rose petal that is symmetric about horizontal axis. So these two are the value of a center xc and yc, and 50 is the value of a, and represent the number of petals. If it is odd, then there are n number of petals. If it is even, then there are two n number of petals. So for example, in this second case, there will be 8 number of petals as seen in the figures, and for the first it will only be 3 number of petals will be 3, for second it will be 8, for third it will be 5, and for fourth one it will be 12. So this is all about drawing the rose family. So now let's see what is behind this method of drawing the rose about horizontal axis. So this has already been talked, so I will be only discussing about this portion of the code. So this portion is used to calculate the radius at first, so we cannot directly plot this into using OpenGL library. So this need to be converted into rectangular format, and symmetricity are also calculated, and finally the points are plotted on the screen. Now this is also another method that is used to plot the rose petals that is symmetric about y-axis. So that's all from my part. Thank you.